Hello everyone! We will discuss today scalar and vector. For you to have a prior knowledge of the two quantities, I will give you a short but brief explanation and samples of each. Scalar quantity only has magnitude and it can only be represented by a number. It does not have any direction, but it follows generic rules of addition of numbers. It includes speed, volume, mass, and time. For example, the car of Mr. Anderson is having a speed of 130 meters per second to be on time on his work. Based on the problem on the screen, there is only one element showed for scalar quantity, which is the 130 meters per second for the magnitude. In vector quantity, it has both magnitude and direction. The vector is known and commonly represented by line segment having an arrow at one end. The arrow describes the direction and the length of the magnitude. This quantity includes momentum, force, velocity, and acceleration. Example for the vector quantity, Joseph is running to go to the church to the east at the speed of 30 meters per second. In this problem, it shows the east is supposed to be the direction and the 30 meters per second is the magnitude. In vector quantity, there is a constituent included, the resultant vector. It is the vector that sum of two or more vectors together. There are two types of method to apply in resultant vector, the graphical method and the component method. Both have different ways to calculate problems. For the graphical method, this pertains to the so-called head-to-tail method, with the uses of arrow, direction, x and y for easy visualization. Here is a quick view of what we will do for graphical method. This uses a ruler and a protractor. First thing to use is the ruler to determine the length of the problem, then we will use the protractor to look for the angle. The direction or position of the protractor in the second vector and so on is based on its direction. It can be tilted or left or right, and repeat the same process until the given is done. In the component method, it is solved by a table or applies a formula to be solved and it's more accurate and has more precise result than graphical method. This method contains a variety of formulas. First, the formula is for x and y component. The formula of x is r cosine theta, for the y is r sine theta. R is meant for magnitude, and theta is for degrees. Next is the resultant vector formula, r equals square root sigma x squared plus sigma y squared. And lastly, formula for direction, theta equals tan minus then sigma y over sigma x. Let's now move on to the solving problem of this video. We will learn how to solve graphical method and component method. First, let's go to the graphical method. A prosecutor is at the crime scene. He saw where the dead body is when there is footprint that is nearly visible. He traced and followed where the footprint starts and ends. The prosecutor determined the culprit's pattern using a meter tape. The displacement were as followed. Footprint 1, it is placed in the entrance door headed to the kitchen 10 miles at the east. Footprint 2, kitchen to the sofa, 6 miles 30 degrees at south of east. Footprint 3, sofa heading to the comfort room 8 miles 25 degrees at north of east. Footprint 4, comfort room to the next footprint is next to be seen on master's bedroom, 11 miles in the angle of 40 degrees at west of north. Footprint 5, from the master's bedroom, the footprint last destination is in the balcony, 12 miles in the angle of 25 degrees at south of west. Today, I will discuss to you how to get the resultant vector using the graphical method. We will now put first the Cartesian plane to graph the problems, and it's very important because we will use this twice in the beginning and in the end. After we draw the first Cartesian plane, we will use the direction north, east, south, and west to identify the lying direction and angle of the word problem. For the first footprint, 10 meters at the east. So the direction state here is the east is based on the example of direction below. The east is towards the right side. And its y-axis is 0 because there is no angle, so it's automatically 0. Using the ruler, measure the length to 10 meters. After we draw the first vector, in the end of the arrow, draw another Cartesian plane because we will draw another vector in here. Let's now graph footprint 2, 6 miles and 30 degrees at south of east. The direction of south of east is in the quadrant 4. We'll use a protractor to find the angle. Always start at 0 and line the angle to the exact direction of south of east. Then measure the length until 6 meters. After that, make a Cartesian plane again to where the arrow ends. And the third vector is 8 meters 25 degrees at north of east. North of east is in the quadrant 1, therefore that is the direction where we will graph the footprint tree. Use a protractor and you may use it sideways or just in a normal position, but measure it in its exact location of north of east. The angle for this vector is 25 degrees. Then we will put a sign or a dot to know where the exact angle is and measure until 8 meters. Let's now draw a fourth vector. The footprint is in 11 meters in the angle of 40 degrees at west of north. The given direction is in second quadrant, so that is where the direction we will put the graph. So the magnitude is 40 degrees, so we'll measure it the same way we measure the other vector. Always put the sign to know where the angle is. Draw the magnitude, which is the 11 meters. Let us now draw the last vector, which is the footprint 5, 12 meters, that is in the angle of 25 degrees at south of west. So the south of west is located in the third quadrant. In getting the angle for this vector is rotate the protractor the left in the angle of quadrant 3 and locate in the exact reference of south of west. With the 25 degrees, put the sign, then draw the magnitude, which is 12 meters. We are now done graphing, but let's now get the final resultant vector of the word problem. So what we will do now is measure the last vector, the arrow of the last vector or the footprint 5, and measure it to connect it in the original Cartesian plane using the ruler. The measured magnitude is 5.9 meters. The origin to the last vector, then we will use the protractor to find the final angle, so the angle is 39 degrees. And to find the direction, see in the graph where in the quadrant of line we use to connect to the last vector. The direction we will use is north of east. We are now done solving the resultant vector for this word problem. So the final resultant problem is 5.9 meters at 39 degrees north of east. We will now go to the component method. First we will do is make a table wherein it includes the given problems, its magnitude, and degrees. Then put two columns for the x and y. Draw a line too to prevent it to be messy. The formula for this table is x equals r cosine theta and y equals r sine theta. But first, we must put the sign for each rows. For footprint 1, the direction is in the east. It's in the right side and all right side direction is positive. So x is positive and y is automatically 0 because it only lies on the x-axis. Footprint 2, its direction is south of east. We will use the Cartesian of direction below. So its direction lies on the quadrant 4. So x is positive, the negative is for y. For the footprint 3, the direction is north of east and the quadrant's direction is quadrant 1 and it's positive and positive. Footprint 4, the direction is west of north, it lies in the quadrant 2, the sign is negative and positive. Lastly is the footprint 5, south of west. The quadrant for the direction is quadrant 3, we know that it's negative and negative. We will now begin to solve the component method. Get your calculators now. We will first solve the first row. First, we will get the x. Type in your calculator the r, which is the 10 meters. Then click cosine, then theta, or the degrees, which is the 0. Then the answer is 10. Then on your y, compute it with the given formula. R is for 10 meters, sine, then the degree, which is the 0. The answer is 0. Just repeat the process. For footprint 2, for the x is 6 cosine 30 degrees. For footprint 3, for the x is 8 cosine 25. For y, 8 sine 25. For footprint 4, 11 cosine 40. For y is 11 sine 40. Lastly is footprint 5, 12 cosine 25. For the y is 12 sine 25. So now when we all get the answers of each rows of x and y, we will add them all. Add all x answers. Type all the answers in your calculator. The same way in the y answers, add them also on your calculators, but separate way in the x answers. Then put x sigma below. So the answer is 3.14. Then for the answer of sigma y, then the answer for the sigma y is 2.38. We will now move on to the resultant vector. The formula is r equals square root sigma x squared plus sigma y squared. So square root 3.14 squared plus 2.38 squared. The answer is 3.94. We will now move on to the angles. The formula is tan minus 1 multiply sigma y over sigma x. So it is solved by tan minus 1 multiplied by 2.38 over 3.14. The answer is 37.16. We are now done solving for the component method. So the final resultant vector is 3.94 meters, 37 degrees at north of east. Thank you for watching!